I know that I stand between you and lunch, so I'm gonna make a deal with you. If you sign up today, we're gonna make this quick. All right? All right, cool. So today I'm gonna talk to you about our enterprise voice AI, Eva, the technical challenges we faced building Eva, and at the end we'll take some questions. So what is voice in the enterprise? Why is it important? We think about voice in three aspects. The first one is actions. So you walk into a room and you say, Alexa, turn on the lights or start the meeting. And this is happening today. But also think about it as information. So it turns out that 20% of search queries over Google, mobile queries, happen over voice. It's a natural way to communicate information and ask for information. But more importantly, conversations. You have them around the water cooler, you have them in meetings. Sometimes you walk into the meeting room and you have no clue what you're gonna discuss, and also walk out with no clue what you just discussed or what you agreed on. So sometimes it's a complete waste of time, circular conversations, and it's never linear, never well understood. So we thought there is this unstructured data that's in enterprise that doesn't actually provide a lot of value afterwards. Once your meeting is done, your voice is lost, basically. IM and email are unlike meetings. They actually have a way to be archived. They're already digitized, of course, and they're searchable. So what if I told you there's a way to get your voice indexed, parsable, structured, and turned into action? That's what we're trying to achieve at Voicera. One of the things we're focused on is actually focus. So one of our goals, if you walk to the meeting room, you don't take your laptop with you. We know what happens. You pretend to actually take notes, but in reality, Facebook messages come in, emails come in, and you lose track of the conversation, pretending that you're taking notes. We want you to stop taking notes on your laptop. And they always say, if your startup succeeds, what's the only thing that people will stop doing? For us, it's taking your laptop to a meeting and taking notes. The second thing is FOMO. We all want to be involved in everything at all times. I want to know about what's happening with our teams, their meetings, want to observe every single meeting that's happening out there, but you just can't be in two places at the same time. When Eva actually can be there for you, Eva can take the notes for you, and then at the end, you can get the notes and important minutes and understand what was going on. With that said, this is Eva, and I want to talk to you about the technical challenges that we faced. One of them is being in every single conversation you have at the workplace, and the second one is how to extract the important minutes of the meeting. So here's an eye chart for you. No talk will be complete without one. It talks about, or it shows you how we actually capture your conversation and conversation, all different channels. We care about having ubiquity, so you can invite Eva to your conversation. If you're having one right now, I'm actually using Eva on my phone. You can call a number via PSTN. You can use one of our apps on Apple or Android. And of course, you can always invite Eva to your meeting, just like any other participant, by inviting Eva at voicera.com. We also allow you to sync your calendar from Google or Office, and we understand which meetings we should be in. So we have some controls for you to say, like, I want you in my internal meetings that I'm organizing, and so on. So the crux of what we're trying to do is actually giving you actionable outcomes from your meetings. And one way to do this is we can take your talk, your conversations, and give you a transcript and tell you, go figure out what's important, right? It turns out a lot of people don't want that. They don't want to listen to the entire recording afterwards. They don't want to read the entire transcript afterwards. And you wouldn't do that, even if you're recording the whole thing. You just want what's really important. And that's what Eva's trying to tell you. So we work on two different dimensions. The first one is actually recommending to you what's important. So we listen. We actually allow you to customize how and when to highlight something. This is an explicit way. You tell us, anytime I hear the word contract, I want you to highlight that this is important. But we also learn Eva becomes more intelligent the more you use Eva, and we can recommend highlights to you. I'm going to talk about that in a second. The other one is way cooler. We actually allow you to interact in the meeting with Eva via voice, just like what you do today with Alexa or Siri. You can activate Eva to highlight something. And we're going to see how we do that. So recommendations. We start with the input text. We do some processing on the transcript, and we come up with some word embeddings. And from these embeddings, we actually run it through a network. And without going into a lot of details about the network architecture, we come up with a class. Is this important to you or not? So imagine your entire transcript broken down into chunks, and each chunk is represented somehow using bag of words, and then through the neural network, it will tell you, that's important for this person or not. Our F1 score is pretty high, it's 0.86, and F1 is a good measure for you to know that we care about precision and recall. So it's the harmonic mean of both metrics. Now, my favorite topic, how did we get Eva to respond to the activation word? So there are a lot of challenges here. When we first started the company, it was very important for us that we work everywhere, including BSDN. And the BSDN, of course, comes with its own set of challenges. You have to operate at a sample rate of 8 kilohertz, and I'm really happy that the audience here understands the difficulty, unlike other machine learning audiences. And this results in clipping and other problems for speech recognition systems. So also turns out that you don't want to hear Eva talking to you unless you speak to Eva. So false positives are extremely bad. You have to be extremely confident when Eva is being addressed. We don't want to interrupt the flow of conversation in the meeting, and definitely we don't want to embarrass ourselves. The third challenge is about the nature of the problem. The more users we get, the newer challenges or the new environments we see are considered new to us, and we have not seen them before. We haven't trained Eva on these microphones, acoustics, or how the meeting room might be set up. A lot of challenges come when you have a new unseen environment, and this is considered a non-IID problem. IID stands for independent and identically distributed. So in our case, it's not identically distributed because the data you have seen before doesn't necessarily or do not necessarily represent the stuff that you're going to see in the future. So how do we deal with all of these challenges? How do we overcome them? Let's talk first about our recipe and what did we do to actually operate a keywording spotter. So imagine the input is an audio stream, and we get the audio frames at 25 seconds each with an overlap of 10 seconds. Each one represents a frame, and each frame is then represented using PLP features, perceptual linear predictors, and MFCC features. And we'll talk about why did we need to include both and not just one. And finally, the input frames or input examples are run through a DNN. In fact, it's run through 6 DNNs. Why 6 DNNs? We have what we call cascaded classifiers. The idea of cascaded classifiers is not novel, generally speaking. It's been actually used a lot in object detection in computer vision. And the idea here is your input data is featureized, and then it runs through the first stage of the classifiers. Each classifier actually includes, or each stage includes 2 classifiers. The first one is looking at the data from the PLP perspective. And PLP is really cool because it actually uses the features that are really important in speech, what they call psychophysics, or how humans actually perceive it. It's much better in certain cases than MFCC. So each one looks at different characteristics of the voice and the speech data and tries to determine, hey, is this okay, Eva, or not? Is this the keyword that I'm listening for? Now, the reason why we have the first stage is it actually looks at the very easy negative examples and just get them out of the equation. So there's an easy answer here. It will not continue. If there is something that needs to be inspected further, it goes into the second stage. So we run the same thing again using different parameters, different classifiers trained at that stage, and it's trained on the harder examples to discern. So 2 classifiers again, BLP DNN, MFCC DNN, and of course you can expect what's coming next, the 3rd stage. And finally, you look at the entire bag of frames that you've been aggregating, and you say, have I heard OK Eva in that bag or not? And that's a noisy OR. And basically, at the very last stage, you say, yes, that's an OK Eva activation. And that's how you get really high accuracy at really good recall. So what did we use? We used something called multiple instance learning, and we used cascaded classification. And we did this for the 8K narrow band audio. You can read more about the details of this approach. We had a paper published at NIPS workshop, and I'm happy to answer any questions afterwards about that. All right, so how did we do? Like I just told you, like, it's really hard. You have to know that Eva is being addressed, otherwise you will be embarrassing yourself. And what performance did we get? Turns out when we did the multi-representation, we got a very nice lift. So the MFCC features on their own, you can see them here, and BLB features on their own are not as good as the multi-representation that when you combine both or you ask both DNNs about the answer. Another interesting lift we got is from the cascades. So if you do just a 2 cascade or a single layer or 2 layers, it's not as good. When you have the 3rd one, you have a much better result. So you're all familiar with this trade-off curve. We really care about how many false positives we get an hour. So that's the x-axis. And then on the y-axis, you can see the false negative rate. And we pick the trade-off point that we think is appropriate for our scenarios. Now, a question that I anticipate here is, like, why not add a 5th or an 8th layer or stage of the cascade? Of course, it slows down in real time. Imagine this is happening almost real time. And finally, we have another problem we did not address, which is what happens when I'm talking in a new environment like this one, and our training system has never heard how the acoustics or the features represented by the speech in this new environment has never been seen before, has never been trained on. What we do is online training. So we have a production system that's running real time, and after the fact, we take the audio and run it again on the same cascaded classifiers, but with lower thresholds. Let's assume the threshold for triggering OK Eva is 0.8. We may take that and actually say, you know what, we're going to lower the threshold and replay the entire audio at 0.5. This allows us to catch things that are false positives or were going to be false positive, and we also trigger any trigger that happens at 0.5. We take it and we consider it again in the training for the next version of the classifier. So this is a very well-posed problem in machine learning. It's very important when you're looking at problems in machine learning, you understand, is it a well-posed problem or not? Meaning that with the exposure to newer experiences, the more time you spend using the system learns and improves automatically. So we're in that position when we talk about our problem. And the second thing, it's also known as the data network effect. It's more data collected and more new samples that actually allows you to increase your performance. With that said, you have a trade-off between recall and precision here, and with time, we're actually increasing the area under the curve, which means great improvements. All right, so I hope I kept my promise. I hope you also keep yours. Sign up today at voicera.com or get the app, iOS or Android. You can also contact me, and I'm happy to take any questions.